All right, let's look at the Chapter 7 homework. So a regression model uses a car's engine displacement to estimate its fuel economy. In this context, what does it mean to say that a certain car has a positive residual? So remember that what your residual is that it is your the difference in the predicted observation and the actual observation, right? So our gas mileage, right, because we're estimating the fuel economy, the gas mileage was better than the model predicts for a car with that size engine. We're doing the observed minus the predicted to get the residual. The correlation between a cereal's fiber and potassium content is 0.898. What fraction of the variability? Okay, fraction of the variability is the square of the R. So 0.898 squared. So round to the nearest tenth, this is 80.6 when I change that number to Tell what each of the residual plots to the right indicates about the appropriateness of the linear model that was fit to the data. Okay, so for plot A, let's look at this. There does not seem to be a discernible pattern here. So that's a good fit, right? Whenever we've got no discernible pattern to it, it's appropriate to use the linear model. Now for B, notice that everything's down here except for that one residual point that's way off from the prediction. But otherwise, they're like falling in a line, right? So the residual plot indicates that most of the data fall roughly along a straight line with the exception of a single point. And then with this residual plot, C, notice there's a curved pattern to it, right? We see a curvature here. That means that a linear model is not appropriate, right? So the curved pattern in the residuals indicates that the model is not appropriate. Determine if the following statements are true or false. If false, explain. All right, choose the linear model that passes through the most data points on the scatter plot. No, it's the one that minimizes the sum of the squared errors, right? So here we go, false. The line usually touches none of the points, minimize the sum of the squared errors. The residuals are the observed minus the predicted. That's true. Least squares means that the square of the largest residual is as small as possible. No, it's the sum of the squares is as small as possible. So the sum of this square of all residuals is minimized. A random sample of records of sales of homes in a city gives the price and size in square feet of 117 homes. A regression to predict price in thousands of dollars from size has an R squared of 62.6%. Write a sentence in context summarizing what the R. Well, remember that's the amount of variance explained, right? And we're doing a prediction of price from size. So size explains about 62.6% of the variation in price. There we go. Oh, 62.6. The regression of price on size of homes in a certain city had R squared equals 75.2. What is the correlation? Well, it's going to be the square root of that. So square root of 0.752 is 0.867. What would one predict about the price of a home, one standard deviation above average in size? The price should be 0.867, the size of the correlation coefficient, standard deviations above the mean price. What would one predict about the price of a home, two standard deviations below average in size? So times 2. Below the mean, so 1.734. A regression analysis of 117 homes for sale produced the following model, where price in thousands of dollars and sizes in square feet. Explain what the slope of the line says. The slope is the item right before the variable, so 0.061. All right, so that's saying for every 1 we go up in square feet, price goes up by about $0.061 thousand. $0.061 times 1,000 would be 61. What price would you predict for a 2,500 square foot house in this market? All right, so we're going to plug 2,500 in there. So we're going to go 47.84 plus 0.061 times 2,500. Okay, that's in thousands, so I got to move the decimal over 3. So we're going to go 200, 340. A real estate agent shows a potential buyer an 1,100 square foot house saying the asking price is $5,500, less than what one would expect. So we want to know the housing price. All right, so let's plug in 1,100. I'm going to shortcut this by just putting the same equation up and changing the 2,500 to 1,100. All right, so times 1,000, right? And then we want to minus the 5,500. Okay, so that would be 109,440. What is the 55? That's the residual. That's the difference in the estimated price and the actual price. A researcher wants to determine if the nicotine content of a cigarette is related to tar. A collection of data in milligrams on 29 cigarettes produced the accompanying scatter plot, residual plot, and regression analysis. All right, we want to know, is this inappropriate? So there's no discernible pattern in our residuals. It looks like a good fit. So yes, a linear model is appropriate there. Explain the meaning of R squared. Okay, so this is tar is being used to predict. So the R squared is saying 92.4% of the variance in nicotine is explained by the tar content. There you go. To the right is a regression analysis of tar and nicotine content of cigarettes. Use the information. Okay, we want to write the regression. So our intercept is a 0.416 and the coefficient is the 0.073. So we want to go intercept comes first, 0.416. And then the slope times the tar is 0.073. Estimate the nicotine content of cigarettes with 8.38 milligrams of tar. So we're going to plug that in. 0.416 plus 0.073 times our tar is 8.38. And we get 3 decimal places. So 1.028. Interpret the meaning of the slope. Okay, so now the slope here is the 0.073. So for each additional milligram of tar, the model predicts an increase in nicotine of 0.073. So that would be this. What does the intercept mean? Okay, so the intercept would be, now notice right here, this is if I have 0 tar, the amount of nicotine would be 0.416. Okay, except it's B0. A cigarette with no nicotine would have B0 milligrams of tar. What? Oh, I wrote it backwards. No tar. There you go. Tar-free cigarette would have B0 milligrams of nicotine. My bad. Sorry, I think I said it right the first time and then selected wrong. Okay. If a new brand of cigarette contains 7.41 milligrams of tar and a nicotine level whose residual is this, what is the nicotine content? So let's plug in 7.41 for the tar. And our residual is negative 0.14, so minus 0.14. Wait, that's the predicted. Hold on. Let me think. Should I add it? Because so it's observed minus predicted, so that means the predicted is. Okay, so 1.097. Put in that 0.416 times 0.073 times 7.41. We get this. Oh, I should have subtracted, not added. So let's go. And the reason why, and here's why I'm saying that. It's a little confusing when you do this, right? It's our observed value minus the predicted value. For it to be negative, the predicted value is bigger, right? So if the predicted value is bigger, I should have subtracted and I added. So that was my mistake. Okay. And, I started to subtract first and double checked myself. So let's just subtract off the one that I accidentally added. Now we're back to the original prediction. Now subtract again. Okay, so it's going to be 0.817. Classified ads in the local paper offered several used cars of a particular model for sale. Listed in the accompanying table are the ages of the car and the advertised prices. Okay. Make a scatter plot of these data. So let's see. 1 is up at 12.9. So this plot is incorrect because 1 doesn't have a point up here at 12.9. So it's one of these two. So this point is different. So this is 5. 87 or 69. So 5, 87, 659, 69, 5. That may be right. This only has 1 at 5. So it has to be A. Describe the association between the age and price of a used car. Okay, so let's run the regression. So I need that data back up again. It's 13 data points. So we're going to go stat, edit, and let's clear out what I have here. And let's go into list 1 and we'll put the age there. So 1, 1, 2, 4, 4, 5, 5, 6, 6, 9, 9, 9, 11, 11, 11, 13. All right, now 12, 9, 40, 10, 9, 45, 10, 4, 55, 10, 9, 70, 10, 9, 75, 6, 9, 75, 7, 9, 90, 87, 20, 6, 9, 95, 59, 60, 49, 80, 32, 40, 22, 70, 39, 45, 29, 50, 29, 65, and 1780. All right, now, by the way, to get this scatter plot, you go into second y equal, plots on, zoom 9, and there's the graph that we were matching it up to in part A. Now to run the regression, we're going to go to stat, calc, option 4. And there we go. All right, now our R is 0.945. That's pretty close to 1. That's strong. So it's negative, linear, and strong. Yes, the linear model is appropriate because the data points form a relatively straight line and there are no outliers. R squared is 89.3. Yep, we got that. What is the correlation? It's the square root of that, but we found it here. It's negative 0.945. Explain the meaning of R squared. That's the percent of variance explained in the price based on the age. 89. Why doesn't this model explain 100%? There are other factors besides just the age of the vehicle, right? There you go. All right. Use the advertised prices for cars of a particular model in the accompanying table to create a linear model. Is this, oh, darn, it's not the same. Okay, we've got to do it again. All right. And this time it's only 10 data points, so I better clear. Okay. 1, 2, 3, 4, 4. 5, 5. 7, 7, 7. 8, 8. 17, 6, 18. 14, 9, 6, 9. 15, 9, 8, 8. 13, 9, 6, 8. 14, 9, 8, 9. 14, 6, 0, 8. 14, 0, 19. 12, 0, 18. 9, 9, 6, 11, 5, 3, 9. 10, 8, 2, 9. 10, 8, 9, 9. 10, 0, 1, 8. All right, now let's run our regression on that. All right, so we have our intercept. Notice the B is by itself, so that's the intercept. 17,984. To the nearest integer, that would be correct. And then the age times the slope. Our slope is the A, negative 878. Explain the meaning of the slope. So every year up in age takes off about $878 from the purchase price. Explain the meaning of the y-intercept. So that means that a new model car would be about 17,984. If you wanted to sell an 8-year-old car of this model, what price seems appropriate? Okay, so we're going to use this with just the integers and hope that that's right. 7,984 minus 878 times an 8-year-old car. 10,960. You have a chance to buy one of two cars. They are about the same age and appear to be in equally good condition. Would you rather buy the one with a positive residual or the one with a negative residual? Because they're asking less than the predicted price. There you go. You see a for sale sign on a 15-year-old car of this model stating the asking price is $5,800. What is the residual? All right, so we want to do the same thing, but 15. So 15. So we want to do 5,800 minus 4,814. 986. So they're asking almost $1,000 too much for the car be above the prediction. Would this regression model be useful in establishing a fair price for a 21-year-old car? So look at our data. It's 10 years old. 21 is way different. So no. Oh, they want us to actually do the predicted price. 0.1-year-old car. But this is outside of our data range significantly, so it wouldn't be good to use it for there. Okay, it's negative. Suppose a researcher wants to examine the association between the amounts of fat and calories in fast food hamburgers. Okay, so let's go to stat, edit. Let's clear this and clear that. All right, so our fat is 21. Nope, calories versus fat. So I want to do calories on the X. Okay, 410. See, I would think you would do fat content to predict the calories, not calories to predict the fat. I'm gonna go ahead and put the fat content in the X, and we'll just switch it if that's not right. Because I would be inclined to predict the calories based on the fat content. That would make the most sense to me. Okay, now let's scatter plot is on. So zoom 9 looks like that. That would be this graph. And then stat option 4. And our R squared is 0.9, so 91.5%. The value of R squared is, which is the percentage of variation in calories that can be accounted for by a linear model and the amount of fat. So 91.5. I'm getting that right here for the R squared. Write the equation. So our intercept is the B, so 189.52. And the A is the slope 11.34. Use the residual plot to make the residual. So I think I in the calculator. I think for L3 I can do L1 minus, no wait. I don't know if I can do a residual plot in here easily. Not without calculating all of them. Shoot. I don't think it does that, does it? Yeah, okay. So to get the residual plot, we would have to actually calculate it. All right, let's put our regression equation in here. 189.52 plus 11.34 times our variable x. Okay. All right, that's our equation here. Now, let's go back into the stat menu and edit. And here we're going to do, let's see if this will work. 410, that value, minus, that's our observed minus the predicted. So now I'm going to go up here and go to vars, y variable, function, y1 of 21. Okay, 570 minus, this is annoying, I don't know a faster way to do it. And that is 32. And then 590 minus 34. And then 580. $36. And then 620. $37. And then 660. $39. And last one, thank goodness, 640 minus 43. Okay. Now, oh, I hope this isn't on here. Okay, good. All right, so now I want a scatter plot of L3. So we're going to go to second, stat plot. It's on, but let's enter there. And we're going to change this, instead of doing like that, we want it to just be L3. So here. And then to 9. Okay, there we go. It seems to be all over the place, right? There's a, we don't have a curve pattern. It shows an increasing spread. Any outliers or patterns? Okay, there we go. Explain the meaning of the y-intercept of the line. That's the 189.52. So that's if we had no fat calories. A fat-free hamburger has 189.52. Explain the meaning of the slope. Okay, so that's every one increase in fat is 11.34 more calories. That's 11.34. A new burger containing 21 grams of fat is introduced. Okay, so let's quit on here. And my equation is 189.52. Oh, I have it stored in Y1. Oh no, yeah, I do. I have it stored in Y1. Okay, so find out y1 of 21. So the model predicts 427.66 calories, but its residual is 37. So 646. Whoops, 464.66. If the correlation between two variables is positive, the slope of a linear model would be positive. That's true. Which of the following is a true statement about residuals? The regression line is the line that minimizes the standard deviation of the residuals. The residual plot for a model that a good fit to the data should not show any pattern, have any unusual features. A residual is the difference between the actual data value and the value predicted by the model. All of the above are true. Okay, guys, that's it for the chapter 7 homework.